This video is about using VBA to access external data. It's part of a continuing series of Excel and VBA best practice videos which focus on manipulating and accessing external data. Videos brought to you by Polaris Investing, a site for creating defensible valuations. As a reminder, business valuation is based on expectations derived from skillful consideration of past facts and future possibility. As a reminder, the series of videos are broken up into Excel-oriented videos and VBA-oriented videos. Excel videos are more focused on user-facing issues, and then the VBA videos are more about behind the scenes, particularly you as a VBA program and how you interact with Excel. The first topic on public datasets related to stocks has been moved to the end of the video. Next, we can talk about the two most common data formats that are used to transfer data. One is called comma separated values, CSV. It's been around a long time, and the other one is the JavaScript object notation, JSON, which was started by Google and is relatively a newer format that's becoming quite popular. So let's look at CSV first. What we're going to do is here in the QueryIt spreadsheet, go over to the prices worksheet and focus on this part of it, columns M through S. Here in column S we have some representative CSV rows, and the convention is to have the first row contain the column headings, in this case first name, last name, age, state, city, state, zip, cell number, and home number. And then the following rows contain data. Now you can see here the way it was built out to have each record on a separate line. We use the line feed character to move down to a new line. And then down here we're showing retrieving data from this text string that's in CSV format. So we indicate what row we want, what column we want, and then over here we use the CSV split out function that was talked about in a previous video. And here you can see we're passing in the string and then the row and the column that we're interested in. Since this is asking for row 1, column 1, we're just getting the column heading of column 1. Row 1, column 3, we're getting the third column, and so forth for row 1. Here's an example of row 3. We ask for the first column and we get Charlie. Further down we ask for the third row, we get Charlie's 37. So it's fairly straightforward. Now as a reminder of this CSV split out function, we have talked about it before. Again, it takes the string and you indicate the row and the column that you're interested in, and then it makes use of the VBA supplied function split. Now you can designate how your lines are split out. In this case, we're saying it's by a line feed. And then later on we take that particular row that we've split out and we call split again, and this time we indicate that we're delimiting the data with a comma, and then it determines the exact row cell and then returns that value after trimming off any leading or trailing blanks. Alright, let's move over and talk about the JSON format, which is shown here right to the left. We've got this text string here that this shows one record. It consists of first name, last name, age, address, phone numbers, but because of limited space here, it didn't show a second record. And that's why you see over here all the designations when we're pulling this data, this row 1. But unlike with CSV formatted data, instead of specifying a position of column, we specify the name of the column. And you can see here the data itself is preceded by the name of the field. So when we go to pull that, the JSON parser, you specify the string, which is up here, and then what instance you're looking for, which is the row, and then you pass in the name of the field that you're interested in. Now notice that JSON trades off clarity for efficiency. Clarity in for each value, right? There's field name of the value, but for each record you're repeating the field name over and over again, whereas over here in CSV format, the first row contains field names, so much more efficient in terms of the bandwidth required to transmit this data. But today, with internet speeds being megabytes per second, transmission efficiency is not that big of an issue. Well, let's go take a look at the JSON parser function. We've looked at this function previously in this video series. This discussion focuses on the input parameter changes incorporated in the latest version. The previous version of this function required this parameter to be the field name and this parameter to be the instant number. Now the values expected in these two parameters are interchangeable. The field name is essentially the column and the instance is the row. It is expected that text to be in one of the interchangeable parameters and an integer in the other. The value of text is considered to be the field name and an integer value is considered to be the instance. If neither parameters are text, then the field name is considered to be unknown. If neither parameters are numeric, then the instance is considered to be 1. If both parameters are text, then the first of the two parameters is used as the field name. If both parameters are numeric, then the first of the two parameters is used as the instance. After the field name and instance are determined from the interchangeable input parameters, the versatile substitute function is used to replace the field name of the instance requested with a string-wide unique character. Next, the find function is used to search for the position of the unique value. This is the starting position of the value associated with the field name. Next, the find function is used again to search for the position of a character that delimits the value. This is the ending position of the value associated with the field name. Make note that wherever the find function is used, the VBA in-string function could have been used instead. Well, this function is further discussed in the context of VBA error handling in the video Data Access VBA Functions around the 4-minute mark. As previously mentioned, this function is not a universal JSON parser. It does handle many types of JSON text strings, but if you have very nested objects in your phone numbers is considered a nested object in this parent object, and if you just have a lot of nesting and what they call arrays, if there's multiple phone numbers that don't have clear field names in front of them, it becomes very difficult to parse. For the uncommon situations where the simple JSON parser is insufficient, there is included in the QueryIt spreadsheet this module called the JSON converter. It contains code from the GitHub. You see here it's called VBA-JSON. And it's a very elaborate, sophisticated, you can see it just goes on and on and on and on. It also requires this dictionary to be downloaded as well from the GitHub site. And pretty involved, but it can be used. In fact, the code example is written right here of how you would use it in place of the current simple JSON parser. But given the complexity this brings in, really advise always trying to use the simple JSON parser first and then go to this if needed. Next, going to discuss this ActiveX data objects API to pull records back from a database. So you go back to this QueryIt application. If we enter MS star, we get back these 12 rows here, and then as we've looked at before, going to see what happened, it called display it, and then here in display it, which we've looked at before, it does call a function called QueryIt. So we want to focus now on that function called QueryIt, and it uses the ADO, so it has to declare some things specific to EDO API set. And we have to do something here to convert between Microsoft Excel wildcards and SQL Server wildcards. And then you can see here the message box that gets displayed. And then we do some more things here, including the connection string and setting up ADO. In this particular connection string, we go out to the Azure in the cloud hosted database. We have a user account and password that's set up for guests, and then we run the select statement, and then it comes back in this array called row array that has been defined as variant. Now when the results come back from the query, SQL returns it as a two-dimensional array, but the first dimension is the columns and the second dimension is the rows. So that's needs to be inverted. So you run the TransposeArray, which is a Polaris provided function. Do not use the Excel provided transpose function, which you could use by using Application.Transpose. But as has been discussed earlier, that provided transpose function has some limitations, particularly around if there's blank values in your array. So use the Polaris provided transpose function called TransposeArray. So you transpose it, and then function returns a two-dimensional array arranged by rows and columns. Now notice the difference between running the select statement here as opposed to say here in the Microsoft tool to run queries. If I run the same query here, I get back with a clear indication of what the column headings are. But when you do it using ADO, you do not get back column headings, you just simply get back the data. Since this video was originally recorded, I have added some additional code that does return the column names. Now, I stated earlier, when you just get rows from the row set, all you get back is the data, no column headings. But here, if you use this attribute called .name with the row set, you can loop through and get all the names of the columns. All right, well, notice in the result that we got from the ADO API, we didn't have to use any functions to handle comma separated values or JSON formatted text. And that's because the array that comes back has the individual values in separate cells of the array, so it's already partitioned out or split out by the time it comes back from SQL Server. Next, I'm going to talk about the HTTP service. So what I'm talking about is, for instance, going out to this site, EODHistoricalData, and then you enter in query, whatever that the site expects. Here I'm entering two particular stocks that I'm interested in getting historical data for. Then I'm saying the date that I want the stock prices for, and then what format I want the data in. You can see here the website returns this JSON formatted data for Microsoft and for Apple, and then I can enter in additional tickers. But there is a maximum number of tickers that you can enter at one time. So if you want more than that maximum, then you have to build in your code some way of breaking up the total tickers that you're requesting into smaller sizes, and request small chunks of tickers at a time in order to get back everything you're looking for. Now this site, you can also specify the format to be in comma separated value. But a lot of sites are going more and more towards JSON only. Well, accessing data using HTTP service has become so common that Excel now offers a function called WebService, and you pass in the same URL that you would type in a browser, and then you can see here it brings back, in this case, JSON data. But I could just as easily use the WebService function and ask for CSV, and would have brought back the same data but in CSV format. Let's look at the prices worksheet on the QueryIt spreadsheet as an example of how you call HTTP service in VBA code. And what we have here in the prices worksheet is we've got a cell here that gathers all the tickers that you would like to include, and we're going to call that same EODHistoricalPrices website for historical data. But we gather up all the tickers that we want to see historical prices for. That's going to be shown here in cell B2. And over here is the actual call to get the historical prices. But as I was talking about earlier, often you need to split up your stock tickers into smaller sizes and then go get the data you're looking for in more smaller increments. And then over here we also do another call, but we get current data. But the one I want to focus on here is this historical. Now the way we invoke that in this spreadsheet, we just click here and it goes off and pulls the data. So behind the scenes, eventually ends up calling this function EOD multiple historic, and you can see here it either uses the string just like you would type it into the address bar of your browser, or based on whether it finds a valid date or not, it will use the string, which ends up describing the price data for the previous day. Then down here you can see the calls you make for the HTTP service, and you make the call and then get a result back, put it in a string, and then there's a return value for this function. Now here in the GetIt spreadsheet we did ask for JSON formatted data, which is assumed by this website if you don't specify the exact format. And then up here in the multiple split function that calls this function and to get chunks of tickers, it then, as it gets back from this function the JSON data, it then loops through and actually puts it in comma separated value format, and then that's what's returned in this multiple split function, and then eventually displayed here as CSV data. And here in the worksheet, pull individual fields by using the CSV split out function that we've talked about in previous videos. Last topic in this video, we're going to talk about using Power Query to pull data. If you recall, we did talk about here when we were talking about the DisplayIt subroutine, that instead of calling QueryIt, which we also covered, you could have had this in your code, and assuming that you had a Power Query called QueryIt, you could have just invoked that query. Power Query loads query results only into an Excel table. You can't load directly into a VBA array. So click in the table area and use the table design menu to choose a table style and whether columns should include the filter button. If you allow a user to select between ADO and Power Query and load the query results in the same location, you will likely want to use none for table style. So that's how you would use Power Query in your VBA code. But the rest of the video we're going to be talking about creating Power Queries and the trade-offs of using Power Query versus the other methods we've already talked about to pull data. When you get to Power Query, is you come here to the Data tab, and then you see over here the Get and Transform Data. Typical way you start off with Power Query is you want to go get data. Now, some common places where you get data are shown here to the right: text or column spaced values from the web. You can even pull data from your own spreadsheet. Let's go back here to the general drop down. So here's the from files, and there we're seeing that from text, but from other files or even from other workbooks, from databases, SQL Server database, from the cloud, online services, other services, the web, and from the spreadsheet itself, which we saw in the quick selection up here. Let's do an example of a data pull by recreating the QueryIt query that, if you recall, we just type in something in A1 and it returns back a result set. So instead of doing that as an ADO VBA code, let's recreate that in Power Query. I'm going to first start off by naming the cell A1. Let's go up here and we're just going to call it ticker. And to see that, we'll go up here to Formulas and Name Manager. You can see here now we've got a named reference to that cell A1 on the page, on the worksheet, page 1. Next, going to go up to Data and create a connection using this other source, blank query. And then we're going to go right into the advanced editor. Once in the advanced editor, just going to replace code there with this code here. And then over here, instead of calling it just query 1, let's call it get value. Next, we'll just simply close and load. You notice over here we've now created a function called get value. Well, next we're going to go back to get data, and this time we're going to get it from SQL Server. And the server name that we're using is off of Microsoft Azure, and the database name is this. In the advanced options, we're going to put the query that we used in QueryIt. Said OK, and it comes back and there's the results that I'm going to go ahead and select transform data. Takes me into the Power Query editor, and then immediately I'm going to go into the advanced editor. Here in the advanced editor, if I expand it here, we can see the whole command line that it's using hard-coded MS, but I want that to be whatever in cell A1. So I'm going to replace this part of the string with that get value function that we defined first. So now we have get value ticker, and then that's a named reference, so it's going to know we're talking about the cell A1 in the page 1 worksheet. Well, next I'm going to indicate that I'm complete with the advanced editor. It brings me back to the normal Power Query editor. You will notice that cell A1 I did go in and put MS %, as opposed to what we were using before was MS star, because star is the wildcard for Excel in Windows, but SQL Server uses %. And since we're passing in directly the value we're getting from that cell into the query, I need to use the SQL Server wildcard. But anyway, here's the result set. And then when I finish up, I simply indicate that I just want to close and load. Now I could also indicate close and load to a specific location, and then when I rerun this query or do a refresh or call it from VBA code, it would run the query and load it where I indicate here. Before I do that, I want to rename this to query to be QueryIt, and then I also want to go out there and check my data source settings. And you can see here if I edit permissions, this is the credentials that it's currently using to log into the database. This database has a guest account called Polaris, and then password welcome exclamation point with a capital W. And now I save. Sure the query still works with those credentials, and now I want to close and load. Now, using a value from a cell in a query is a little trickier than it appeared. We had to create a function called getValue. We had to use the advanced editor when setting up this query to use getValue and reference a named reference that you had to previously define. So keep those things in mind. It's not quite as straightforward as you think it should be. Another thing to be aware of, if you wanted to change where the query results are loaded, you would right click over here in the queries pane, do load to. You would say you want a connection only, meaning it's not going to load it. Come up and give you a warning. You go ahead and see it removes it from the current worksheet. Then you come back and right click, do it again, load to. This time you say I want to put a table on a worksheet. You can specify a new worksheet or the worksheet that you're currently in, and then hit OK. The thing to keep in mind in this QueryIt spreadsheet, method of pulling data is determined by the value on the managed worksheet. If it's set to Power Query, then we run this statement in the VBA. If not, we call this function, which is a function that uses ADO. The Power Query exists regardless of the execution path in the VBA code. This means the user can manually come up here to the Excel data menus, select a specific query, or just simply say refresh all, and the Power Query will refresh. And just to demonstrate that, let's go ahead and run the application like it's intended, and you see the query result here. Now if I go and clear out this query result, but not come back to cell E1, which is the way that this QueryIt spreadsheet was designed, and as a user I just come here and do data refresh all, or refresh this specific query, but I'll do refresh all. Even with the ADO method of pulling data selected, the user still can manually run a Power Query. So for complete VBA control of data pull, it's advised to just use the ADO method. Let's do another example, this time pulling in JSON data. Stock quote information I'd like to pull in about Microsoft, Apple, Netflix, Twitter, and Disney. So here's the URL that I use in the browser. You can see here that it brings back JSON formatted data dealing with those 5 stocks. We'll notice here that the layout of this is that it includes nested objects. It's actually got an object at this level and then another object called quote. That's where all the data actually resides. Now notice there's null values for quite a few of these fields for each of the stocks. So it's things like that that you'll typically want to clean up, and also maybe specify exactly which fields you're interested in. So let's use Power Query to pull this data into the spreadsheet. I'm going to make note of the URL that I used. I'm going to come out here and say from web, enter in the URL, and then we're going to go into the Power Query editor, and we'll see here that it's already pulled the data back. Recognize it is JSON, and the way that JSON is organized, I want to say to table, and then I want to do a thing called expand. Do not want to use any kind of prefixing. And then I need to expand again because of the nested objects. And now I expand again, and now I get all the columns. You can see here that it even brings in those fields that had null values. The real power of Power Query is its ability to change the data around, or what is called transform. Therefore, the other name is get and transform the data. So let's say I want to get rid of all the columns that I don't plan on using. So here, calculate things with null values in them. And when I've got everything identified, you just come up here and say remove columns. And notice over here under applied steps that Power Query is keeping track of the steps that I'm going through to transform my data. And then when it saves off the query, it also saves off all the steps. So if anytime I want to refresh, it'll run the steps again, go grab the data from the URL that I used, and then do the expansions and remove the columns. And the last step here is you want to load it into your spreadsheet, and you can either load it to a very specific worksheet in a specific location in that worksheet, or if you just say load, you'll create a new worksheet and load a table. Let's say you've got everything the way you want it, so you're off doing other things in your spreadsheet, and now you want to go back and do something to that data pull. You come back out here, you select queries and connections, and select this query that you've previously defined, and then you can come back and edit it. I'd like to go over a little more detail. The steps over here that are shown to the right. If you go into the advanced editor, those steps are now shown essentially in a programming language, and it's called the mQuery language. And M stands for mashup, and it's a way to generate additional functionality that's not inherent in the user interface that Microsoft provided. Now, there's quite a bit of available information out on the internet on this Power Query M language. You see here one site, Microsoft site, that has all kinds of references. Also plenty of YouTube videos that go into this language in a lot more detail. But it's basically not a language that's intended really for novice end users. It's really if you're doing some little heavier lifting in terms of kinds of data pulls you're trying to do. Things beyond the normal, like removing columns, removing top and bottom rows. Let's do a quick example of doing something that's beyond the user interface is provided. Let's say that I wanted to duplicate this row here in row 1. I'll go out to the advanced editor right after I get done removing columns, which is the last step that's currently in the M language. I would go to the end of that, put a comma at the end, and then add this additional row, and then I call it a name new row. Then down here I have to specify the last step, new row. And now when I come out here and look at what I've got, you'll see that I've replicated the first row. Now, just duplicating a row is not a real practical use of the M language, but it does demonstrate some things. So here's the row that was added. You can see what it does is it references the previous step, and then it makes reference to where in that results set for the previous set, namely row 0, that you want to insert in addition to back into the result. Note M language references rows from 0 to n-1, not from 1 to n. Other examples down here where you can do an insert, but here you're specifying the exact values of individual columns. You're either saying I want to use the same row 0, you can specify exact value here, and then like it's done here. And then you can even do conditional statements. You can in the insert you can do, if the first row from the last step's result says equal to something, then set this new row's value equal to a value, else set it to something else. As you get to know the M language, you'll see that it has quite a bit of flexibility, much beyond what was brought forward in the Power Query editor. Now we've seen what Power Query, early on the surface, what Power Query can do. The question comes up, well, why not use Power Query for pulling all your external data? Well, Power Query is really orientated towards more exploring and an individual sitting at their computer wanting to pull in data from different data sources, and some of those data sources doesn't have real clean data, so it allows you to clean the data up. And I think of it more of like a garbage collector and recycler kind of functionality, where in most cases when you're developing applications, you have clean data sources. You're pulling from a SQL Server database. You run your query, you're only pulling back specific fields that you're interested in. So if you're doing broad bulking in data from a lot of different sources, exploring, Power Query is an appropriate tool. But if you've got specific data sources that you can rely on in terms of clean data, and you want to pull specific and be more surgical with your pulling of data, best to use some of the other methods we talked about previously. Okay, now going to talk about the topic that was moved to the end of this video, namely public datasets related to stocks. A recent article titled Best 5 Free Stock Market APIs. And it lists the following APIs, and then it makes reference to other APIs. Well, to briefly talk about these, Yahoo Finance, yes, most people are familiar with Yahoo. They've had some APIs available that because they're free, that they've later deprecated and eventually made unavailable. They've offered new APIs. It's just in general, when you're talking about free market data, you're susceptible to the data source changing on you with little notice and having big impact if your code is written in such a way that's very dependent on that particular data source. So recommend not using free stock market APIs in general. They're good for some things, but should be avoided in lieu of paid APIs to get a more consistent and supported data access. Google Finance, they have an API as well. Over the years, their API has been available and sometimes not available. IEX Cloud, that's a good data source for current market data, although it has limitations as to which markets it provides stock price information for, particularly price. Alpha Advantage is a reasonably good source also, primarily for price data. Two paid services that I have found to be very reasonable, particularly for an individual. One is offered by the American Association of Individual Investors called Stock Investor Pro. It's actually a program, Windows-based program that you can download, and then from there you can download into the program and export out of that program Reuters stock data and fundamental data. The data is available Saturday morning for the previous week, so it does not give you real-time data, but for the price of around $300 a year, it's very reasonably priced. Another source, primarily for pricing data, is a company called EODHistoricalData. Now, the name historical data is a little misleading because they have expanded their services where they also offer fundamental data and also current price data. And by the way, their service is very reasonable. If we go here and look at some of the pricing options, you can see here you can get going as little as $20 a month. They have a nice customer support arrangement where you go to their site anytime, click on this message looking box in the bottom right hand corner, and they fairly quickly respond to any questions you may have. So when you subscribe to their services, you just go out to a website, you're given a token that you enter in, and they do have throttled access. You get so many accesses per day. With a $30 subscription, you get something like 100,000 accesses a day, and then you can specify what kind of format you want the data to come back in. And for instance, here's an example of in JSON format. Some other sources of financial data from the financial data industry is well-known names like Bloomberg, Capital IQ, FactSet, direct access to Reuters data, Zacks, Morningstar, Microsoft, Azure has lots of data sets to choose from. And overall, this is just a very rapidly expanding segment of the industry. Example of just how quickly this part of the industry is evolving. Google just announced a site called Dataset Search that lets you go out and look for free data set. Clicking on Learn More, go out and look at the launch announcement. Main purpose is making it easier to discover data sets. For instance, if I search for stock fundamental data, comes back with all kinds of data sets. You notice a lot of these hits are a site called Kaggle. Well, that's a site that's owned by Google. So here we have a search engine that's on data sets that just came out from Google, and then one of the main data set sites that it references is itself Kaggle. But Kaggle has quite extensive set of data sets, and if I search its site for stock fundamental, see you get for the New York Stock Exchange all kinds of data sets that I can even pick whether I want to download it in JSON or CSV. Availability of public data sets is evolving quickly. A lot of ways to find and pull data sets off the internet. It's also almost an endless supply of data if you consider grabbing data from websites, other people's spreadsheets, just all kinds of sources of data. But in general, I would discourage web screen scraping, and even though there's tools like Excel's Power Query. Problems include the web page can change with no notice, and tends to be slow and inefficient. Also, there's a legality issue with the Supreme Court is recently ruling any public information scraped from a site has restricted commercial use. On this video, we covered public data sets that are related to stocks and financial data. Talked about common formats that data is in, CSV and JSON. We talked about two approaches programmatically to go grab data, namely ADO and HTTP servers. And finished up here talking about the pros and cons of Excel's Power Query. So thanks for watching.